In this video, we'll be looking at how to simplify and expand logarithmic expressions. And if you are not subscribed to this channel, kindly subscribe. Now, in example 1, it says given log p to be equal to x and log q to be equal to y. Express log pq divided by 1000 in terms of x and y. Now, this simply means that we want to simplify log pq out of 1000, and at the end, our answer, we should see the presence of x and y, and that's very simple. Now with this, we were given some parameters and they are log p, which is equal to x. Now this log p implies that it is in the base 10. So we said a logarithm of which its base is not written means that that logarithm has a base of 10. In the same way, when we come to the other one, we're also given log q to be equal to y. This also implies that this log q has a base of 10, though it's not written. Now we want to find log pq divided by 1000. So it simply means that we have to apply the laws of logarithms. Now, this is a logarithm which has been written as a single logarithm, and we can apply the laws of logarithm to expand it. Now, it means that log pq, we can write it as log pq base 10, like we said. Now, a single logarithm and they are being divided, which means we can expand by subtracting. So logarithm of 1000 base 10. Now if that is known, then we can also expand log pq. So log pq is seen as a single logarithm being multiplied, so we can expand by adding. It implies that we have log p base 10 and then plus log q base 10. Now we have minus logarithm of 1000 base 10. Now we continue with our solution, and at this point we can maintain log p base 10 plus log q base 10 and also simplify that of log 1000 base 10. So that is log p base 10 plus log q base 10 minus log. Now 1000 simply means that 10 exponent 3, so we have 10 exponent 3 base 10. Now before we substitute the value of p and q, we can also maintain it and work on log 10 exponent 3 base 10. So that is log p base 10 plus log, now let's take it back. So plus log q base 10 minus, now at this point we can see that log of 10 exponent 3 base 10 can be written as 3 log 10 base 10 by applying the product index rule or the product index law. Now we know the value of log p base 10 to be x, and then we know log q base 10 to be y. So we are just going to do substitution wherever we find it. So that implies that our log p is known to be x. So at this point we substitute x here, and log q we said is y. So minus 3 multiplied by a logarithm of a number to the same base is 1. So that's log 10 base 10 gives us 1. And at this point we have x plus y minus 3. So it implies that our logarithm of pq out of 1000 can be expressed in terms of x and y as x plus y minus 3. And that becomes the solution to this question. Now let's try the next example. Example 2 says that given log x base 10 equal to a and log y base 10 equal to b, express log 10 exponent, so 10x exponent 3 divided by the square root of y in terms of a and b. So you just want to express log 10x exponent 3 divided by the square root of y base 10. Now we have to do that by considering log x base 10 and log y base 10, which are equal to a and b respectively. And at this point, if you have not subscribed to BakoMaths, kindly spend a moment and subscribe. So we have a, so logarithm of x base 10 to be equal to a, and also we have logarithm of y base 10 to be equal to b. Now the main focus is for us to express logarithm of 10x cubed divided by the square root of y. Now with this, it has been written as a single logarithm, so we can apply the laws of logarithm and then expand, which means we can take logarithm of 10x cubed. So we have logarithm of 10x cubed as one term, and minus, now in the single logarithm you can see that they are being divided, so we can write it by expanding, knowing well that this division is going to serve as a subtraction here. So we have logarithm of, at this point we have square root of y base 10. Now we continue and we can see that this logarithm of 10x cubed, they are being multiplying, or they are being multiplied, which means that we can also expand by applying the laws of logarithm such a way that we are going to add them. So that is logarithm of 10 base 10 and then plus logarithm of x cubed base 10. Now we maintain our logarithm of, now square root of y, we know square root is the same as half, so we have y exponent half base 10. Now we know that the logarithm of a number to the same base is 1. That is log 10 base 10 gives us 1. So we have 1 here plus, now logarithm of x cubed base 10 can be written as 3 log x base 10. That is from the product in this law. And then the same thing implies to log y exponent half base 10. So that is half log y base 10. Now with this, we were given the values of log x and log y. Now initially we were given log x to be a and then log y to be b. So in our simplification, we can see log x here and we can see log y here. So it means that we are going to do substitution. So then by substitution, we can see that we are going to have 1 here plus 3 maintained. Now log x base 10 is given as a here, so we have multiplied by a, minus half. Also we were given log y base 10 to be equal to b, so we have b here. Now we simplify, we have 1 plus 3a and then we have minus half b, and this becomes the solution. So this implies that our logarithm of 10 s cubed divided by the logarithm of y to the base 10 is equal to 1 plus 3a minus half b, and that is how we can simplify it. Now, having known this, let's try our last example for today's video. In example 3, it says that given log a base 10 to be equal to p plus q and log b base 10 to be equal to p minus q, express I log a exponent 3 multiplied by b exponent 3 base 10 and I logarithm of e out of 100b base 10 in terms of p and q. So we are just going to express the second one in terms of P and Q. But for the first one, it's a different question on its own. We are not going to express in terms of P and Q. Now at this point, you can pause the video and try your hands on. So we have been given the logarithm of a base 10 as P plus Q, and also our logarithm of b base 10 as P minus Q. Now with the first one, that is the I, you want to express log a cube b cube base 10. Now this is a single logarithm, and we can expand it by applying the laws of logarithm, which means that we can have this as logarithm of a cube base 10 plus logarithm of b cube base 10. Now this is the meaning. So originally it was like this, and they simplified it to get logarithm of a cube b cube base 10. Now with this, considering logarithm of a cube base 10, it can be written as 3 log a base 10, and the same thing when we look at logarithm of b cube base 10, it can also be written as 3 log b base 10. Now we know that the value of log a is the same thing as P plus Q, and we know the value of log b base 10 as P minus Q. So having known that, we are going to do quick substitution, and we have here as 3 multiplied by log a is known as P plus Q plus 3, and log b is known as P minus Q. Now we continue, and we can see that we can expand. Yeah, so 3 multiplies P plus Q, then we have 3P plus 3Q plus 3P, and then we have minus 3Q. Now at this point, we can group like terms by first bringing the p's. So we have 3P, the first 3P here, and we have the last 3P, and the first 3Q here, so plus 3Q, and the last 3Q, so minus 3Q. Now if that continues, then we can see that 3P plus 3P gives us 6P, and 3Q minus 3Q gives us 0. So that is that. So this implies that the logarithm of a cube b cube to the base 10 is the same thing as 6P, and this is the solution. Now let's try the next one. The next one said that we should express log a out of 1000b base 10 in terms of p and q. So let's write. So we have logarithm of a out of 100b base 10, which is equal to, now this has been written as a single logarithm, so we can break it down by applying the laws of logarithms. It implies that you're going to have logarithm of a base 10, and we can see that in the single logarithm they are being divided, so we can write it as minus, if you are expanding, then it becomes minus logarithm of 100b base 10. Now we want logarithm of a base 10, so if we have it now, then let's maintain it, minus. Now when we come here, we have logarithm of 100b base 10. With the 100b, it implies that they are multiplying, so we can also break it down into addition, that is by applying the addition of logarithm. Then we are going to have Now you have to put it in bracket because the minus is affecting 100b. So if now we are expanding, the minus would affect everything. So that is 100 base 10, and then we have here as plus logarithm of b base 10. Now we have logarithm of a base 10 minus logarithm of 100 base 10, and minus multiplies my positive. We are going to have minus logarithm of b base 10. Now we continue, and we have logarithm of a base 10. Now minus 100 can be expressed as 10 exponent 2. So we have logarithm of 10 exponent 2 base 10 minus logarithm of b base 10. Now we maintain logarithm of a base 10 minus, so 10 exponent 2 can be written as 2 logarithm of 10 base 10, and maintain that of logarithm of b base 10. Now we say that the logarithm of a number to the same base is 1. So it means logarithm of 10 to the base 10 gives us 1. Minus 2 multiplied by 1 minus logarithm of b base 10, and not forgetting logarithm of a base 10. Now at this point, we can further simplify. You have logarithm of a base 10 minus 2 minus logarithm of b base 10. Now initially we're given the values of logarithm of a and b, so that is, but the logarithm of a base 10 was given as p plus q, and that of the logarithm of b base 10 was also given as p minus q. Then by substitution, we are going to have here as logarithm of a, but the logarithm of a, like we said earlier, is now p plus q. So we write here as p plus q minus 2. Now let's clean the minus 2 and write it 1. Yes, so minus 2 here, and minus, so our logarithm of b base 10 is now p minus q, but there is a existing minus here, so let's put that in bracket, minus q. Nice. So at this point we have p plus q minus 2, so minus p here, and minus gives us plus, so plus q. Now we can see that we can group items here. So we have p first, minus p follows, and we have the first q, and then the second q follows, and we have our minus 2. Now we can see that minus p and positive p gives us 0, and then q plus q gives us 2q, and then we have minus 2. So at this point, our value of logarithm of a out of 100b base 10 is the same thing as 2q minus 2. And this becomes the solution to this question, and our video ends here. And so thanks for watching. Kindly like, comment, subscribe, and share. BakoMaths, thinking beyond infinity.